Good morning to everyone. I am Sangeeta, professor from IT department, K.S.R. College of Technology. Today we are going to discuss about TCP/IP protocol suite. This TCP/IP model was developed prior to the OSI model. This model contained 4 layers. That is, what are the layers? That is host network layer, internet layer, transport layer and application layer. The first 4 layers are used to define the physical standards, network interface, internetworking and transport functions. The last 3 layers, that is the topmost 3 layers are combined and named it as application layer in TCP/IP protocol suite. This TCP/IP protocol is a hierarchical protocol which defines the specific functionality for each and every layer, because this TCP/IP layer contains a number of protocols which is used to define the functionality of each layers. This is the model of TCP/IP. Here actually we start from lower to bottom. The first 2 layers, physical layer and data link layer, in OSI model is combined as host to network layer. The first 2 layers of OSI model, physical layer and data link layer, combined as host to network layer. The next second layer is network layer. That is, we call it as internet layer in TCP/IP model. This layer contains 5 protocols. That is IP, Internet Networking Protocol, ICMP, Internet Control Message Protocol, next IGMP, Internet Group Message Protocol, then ARP and RARP. ARP is nothing but Address Resolution Protocol, RARP is Reverse Address Resolution Protocol. The next layer is, that is, third layer of TCP/IP model is transport layer, which contains 3 protocols. That is TCP, UDP and SCTP. TCP is Transmission Control Protocol. It is a connection oriented protocol. And UDP is User Datagram Protocol. It is a connectionless protocol. SCTP, Stream Control Transmission Protocol, which is the combination of TCP and UDP. That is, which combines the best features of TCP and UDP. The next, that is a last layer, is 4th layer of TCP/IP model is application layer. The last layer of TCP/IP model is application layer. That is here session layer, presentation layer and application layers of OSI model is combined as application layer, which is combined and named as application layer. So totally TCP/IP model contains 4 layers. The first layer is host to network layer, second layer is internet layer, third layer is transport layer, fourth layer is application layer. First we are going to discuss about the first layer of OSI model. First layer of TCP/IP model. That is, the first layer is host to network layer. That is, combines the features of physical layer and data link layer. This layer supports all standard protocols because it does not define any specific protocol. That physical layer and data link layer does not define any specific protocol, which supports all standard and proprietary protocols. The second layer is network layer or internet layer. This main responsibility of network layer is which is used to transfer the packets from source to destination, and also this layer supports the routing and internetworking functions. This protocol, some few protocols are used in this layers for IP, ICMP, IGMP, ARP and RARP. Here the packets are in the network layer. The data are delivered in the form of packets. The data are delivered in the form of packets, and also this layer supports the source to destination delivery. This layer supports the source to delivery. Here the data are transferred in the form of packets. Here actually the packet is called as datagrams. Some of the protocols used in internet layer is, first protocol is Internet Networking Protocol. It is an unreliable and connectionless protocol. It is a connectionless protocol, so we call it as it is unreliable, which provides the best effort delivery for the users. Why it provides the best effort delivery means because there is no error checking mechanism, there is no tracking mechanism, because it is a connectionless protocol. So there is no connection, so there is no error checking, there is no mechanisms. So we call it as it provides the best effort delivery for the users. And also in IP protocol deliver the packet in the form of data graphs. So it takes the different routes and arrive at the destination. The next protocol is address resolution protocol, which is used to find the MAC address. That ARP is used to find the MAC address or physical address when we know the internet address. When we know the internet address, we can find the MAC address or physical address. MAC means we know that medium access control. Medium access control. The next one is reverse address resolution protocol, which is used to find the IP address, that is internet address, when we know the physical address of the host or device. So if we know the physical address, we can find the internet address. So with the help of RARP, we can find the IP address. With the help of ARP, we can find the physical or MAC address. The next protocol is Internet Control Message Protocol. So this protocol is used by the host, routers or gateways to send the notification of datagram problems. So when we are transmitting the packet from sender to receiver, the packet may be lost, the packet may be dropped. So these problems are noticed to the sender with the help of ICMP protocols. So to report the error message, to report some notification, we can use this protocol, Internet Control Message Protocol. The next protocol is Internet Group Message Protocol, which is used by the host and router to support the multicasting. To support the multicasting, we need the Internet Group Message Protocol. The next, that is third layer of TCP IP model is transport layer. This layer is responsible for process-to-process delivery. That is end-to-end delivery. That is process-to-process delivery. We are going to transport layer. In this layer, we are transmitting the data in the form of segments. We are transmitting the data in the form of segments. This layer supports the flow control, error control, and also reliability functions. The three protocols used in this layer is TCP, UDP, and SCTP. So we know that TCP is Transmission Control Protocol. It is a connection-oriented protocol, so it is reliable protocol for the user. So it is connection-oriented protocol, so it is reliable. So when we are sending the message with the help of TCP, the message is divided into number of segments and transmitted to the destinations. Based on the sequence number. So finally, this message is received by the destination and arranged based on the sequence number. TCP is a reliable protocol. So because it is a connection-oriented protocol, so at the sending end, TCP, when we want to transmit the data, TCP divides the whole message into smaller units, that is called segments, and it is transferred to the receiver. So when the receiver receives a message from the source, it rearranges the packets based on the sequence number. Next protocol is user datagram protocol. It is a connectionless protocol which provides the end-to-end delivery. It is unreliable protocol because there is no connection in the UDP. So the UDP, in this UDP protocol, the packets were transmitted in the form of data graphs. So finally it transferred from the source and reached the destinations it takes different paths and reach the destination. The next protocol is Stream Control Transmission Protocol. That is SCTP. It is a connection-oriented protocol which is used to transmitting the multiple stream of data simultaneously from the sender to receiver, which is used for supporting the telephonic conversation on internet, that is voice over the internet. That is the purpose of SCTP, which combines the best features of UDP and TCP. The fourth layer of TCP IP model is application layer. This is the topmost layer in the TCP IP model. Here, the application layer in TCP IP is equivalent to the session, presentation, and application layer of OSI model. That is session, presentation, and application layer of OSI model is combined and named as application layer in TCP IP model. So what is the purpose of this layer? This layer is helpful for interacting applications in the internet. Suppose user interact with the applications available in the internet. This layer provides some of the protocols. Those are Telnet, SNMP, DNS, HTTP, FTP, SMTP. So we know that SMTP is the simple mail transfer protocol, FTP is the file transfer protocol, DNS is the domain name service, SNMP is simple network management protocol. So these protocols are used for us to interact with the applications. Finally, we are going to discuss about TCP IP model and OSI model. That is, TCP refers to the Transmission Control Protocol. OSI refers to the Open System Interconnection. TCP IP has 4 layers. OSI has 7 layers. TCP is more reliable. TCP is more reliable. OSI is less reliable. TCP IP follows horizontal approach, but OSI follows vertical approach. TCP IP developed protocol then model. In TCP IP protocols, that is, protocol is developed first, then model is developed. But in OSI, model is developed first, then protocol is developed. The TCP IP model provides the connectionless services, but OSI model provides both connection oriented and connectionless services. So finally, protocol in TCP IP model, protocol cannot be replaced. Protocol cannot be replaced based on the current trends, current technology. But in the OSI models, we can replace the already defined protocol based on the current trends, current technology. We can change our protocols. So this is the difference between the TCP IP and OSI model. Okay, thank you students. Thanks for watching. Thank you.